Hello students, let us today see at the second problem of LPP. A manufacturer produces two types of models, M1 and M2. Each model of type M1 requires 4 hours of grinding and 2 hours of polishing. Means there is a grinder and there is a polisher here. Okay. Whereas each model of type M2 requires 2 hours of grinding and 5 hours of polishing. The manufacturer has grinders, 2 grinders and 3 polishers. Each grinder works for just 40 hours a week and each polisher works for 60 hours a week. The profit on M1 model is rupees 3 and model on M2 is rupees 4. Whatever is produced in a week is sold in the market. How should the manufacturer allocate his production capacity to the two types of models so that he makes maximum profit in a week? So here they have actually asked for the entire problem. They have asked us to find out what is x1 and what is x2. But what we are going to do is we are just going to formulate this problem because as of now we are just focusing on formulation of LPP problems. So let us solve this problem. Okay. Now, the firm manufactures two products, that is M1 and there is one more product called M2. Now, each of these products require grinding and polishing. So there is a process of grinding and polishing. Okay. Now, as you have seen in the problem, that M1 requires 4 hours of polishing and 4 hours of grinding and 2 hours of polishing here. And machine M2 requires 2 hours of grinding and 5 hours of polishing. Now, the profits on the products M1 and M2 are if the profit on product M1 is rupees 3 and the profit on M2 is rupees 4. Now, what we are expected to do here is to understand the constraints of grinding and polishing. Now, the grinder, how many grinders are there? There are 2 grinders and each are available for 40 hours. Okay. So 2 into 40 is each total grinding hours are 80 hours. Okay. Similarly, there are 3 polishers and each are available for 60 hours. Total duration which what we have is 180 hours. Now this, in the previous problem, here each of the products were going into the machines in minutes. The machines were available in hours. So we converted the hours into minutes because here it was minutes. Now here these figures are in hours and these are also in hours. So we don't need to convert because both are in hours. So we are going to find out how many products of M1, that is X1 products, that is how many number of M1 products to be produced, and we also need to find out X2, the number of M2 products to be produced. So first what we are going to do is we will find out the objective function Now, of course, since they are given profits, the main objective function is to find out uh, what will be the total profit. So here we are trying to, the total profit is Z. Okay, now Z is equal to the profit on product M1 is 3. So 3x1 plus 4x2. What we are trying to do here is we are not going to minimize the profit, we are going to minimize the cost if it is a cost problem. Here it is a profit related problem, that's why we are going to maximize the profit. So first step is done, we have done the objective function. Second step, we have to go for understanding the constraints in this problem. Now the first constraint is grinding constraint, then polishing constraint. This is basically just a time constraint for both of them. Okay, so the first basic time constraint for grinding is 4x1 that is 4 hours of grinding for M1 and 2 hours of grinding of X2, that is M2. X2, which should be this, all this grinding should be less than or equal to 80 hours. So this is the grinding constraint. This is the grinding constraint, and let's take it for polishing constraint, that is 2x1 plus 5x2, which should be less than or equal to 180 hours. So these are the constraints which are there. There are no other constraints other than these two constraints. So let us go for the non-negativity constraints. So of course, we cannot produce x1 and x2 in negative. It will be minimum be 0 and it might go to any level. Okay. So therefore it will be x1 is greater than or equal to 0. Sorry. This one is greater than or equal to 0 and x2 is greater than or equal to 0. This is the solution for this one. Thank you. We'll continue in the next problem.